Okay, hi everybody. Today we're starting chapter 2, which is about descriptive statistics. Today we're going to be talking about stem and leaf plots, or stem plots, or stem and leaf graphs, line graphs, and bar graphs. We're also going to be talking about histograms and not box plots. Sorry, histograms and and time series plots. Okay, so let's go ahead and start. In this chapter, you will study numerical and graphical ways to describe and display your data. This area of statistics is called descriptive statistics. Statistics. Okay, you will learn how to calculate and even more importantly, how to interpret these measurements and graphs. All right, so a stem and leaf graph. One simple graph, the stem and leaf graph, or stem plot, comes from the field of explanatory data analysis, which is or exploratory, not explanatory, exploratory data analysis. What they do in exploratory data analysis is they try and find patterns and stuff. So they're sort of exploring with different representations of data to see if they can determine a pattern or some other form of structure. Okay, it is a good choice when the data sets are small. So stem and leaf plots is a good choice when the data set is small. To create the plot, divide each observation of data, that's a single datum, like 94, divide it into a stem and a leaf. The leaf consists of a single final digit, and that's important, a single digit. Okay, so here's an example of a stem and leaf plot. So let's investigate this. So the first data that we have here is 94, and so that can be split up into a stem and a leaf. The stem will be at the 9, the tens place, and the leaf will be the ones place. And this gets put on the graph like this. You find the stem, and then in that row you put in the leaf, 4 in this case. And so we take the next number and we plot another 4. We put another 4 down. And then the next number, that stem, is 5. So there's 94, here's 55. That stem is 5, and as you can see, it's represented there. And you do that all the way till 69 when you're done. Great. So you can see here that for every leaf represents one of your data points. Okay. This 9 right here represents the data point 49, which is here. There's 2 9s because there's 2 49s. Let's see, where's the other one? There it is. There's 2 49s. Anyway, and so you plot that. And notice what this thing tells. Oh, and then you rearrange it in ascending order to make it easier to see. Notice what you can pick out of this. You can see sort of which tens which tens has the most numbers in it. The 60s. The 60s has the most data points in it. Or actually, I think it's tied, right, with the 90s. Okay, so anyway, so it gives you a bit of a shape of the, spread. Okay, here's an example. The data are the distances in kilometers from a home to the local market, from a home to local supermarket. So there's a lot of supermarkets. Create a stem leaf plot for the data. All right, so this data is already arranged in order, and so that's good. So we've got here's 1, and then 0.1. That one shows up there, and this 1.5 is represented by that leaf, 2.3 is represented by the 3 there. Do the data seem to have any concentration of values? And the answer is yes. The values appear to be concentrated at 3 and 4 kilometers. And there is something, there's 12.3. Notice there's a big gap here, and this one's all by itself, that 12.3. That's what we call an outlier. Oops, outlier. Okay, great. Okay, now I want to talk about so that's stem and leaf plots. Now I want to talk about line graphs. So another type of graph that's useful is a line graph, and here's an example. So if you've got data such as you have this data, the number of times that teenagers reminded to to do their chores. So what happens is you polled a number of mothers, 40 mothers, and they give you the number of times per week they need to remind their kids to do their chores. And so 2 of them said 0, 5 of them said 1. So you see, the original data here is just a list of numbers, just like with the stem plot. And so what they did was they found the frequency. They counted up all the frequency, all the times that 1 was used. And then what they did is they go to the plot here, and now they're going to plot these frequencies. So on the x-axis, you have the actual data values. And on the y-axis, you have the frequency of each data value. You plot that. So here's 0, I'll go to 2, 1 goes to 5. And then you draw lines in between it. And that's your line graph. It's very easy to see which one is the most frequent, which we'll refer to as the mode. Okay, bar graphs. Bar graphs consist of bars that are separated from each other. 3 bars, these bars can be rectangles, or they can be rectangular boxes used in 3-dimensional plots. So like what I'm drawing here, for instance. And then, so something like that. Yeah, 3-dimensional plot. They can be horizontal, as well as vertical, as shown below. Great. And what they do is you just find the proportion that they represent. And so I think we've seen a bit of these before, bar charts before. This bar charts and Pareto graphs. Okay, and so on the x-axis you have the categories. So this is mainly for categorical data, and the proportion of the whole population that falls into that category. And so here's a group right here from 13 to 25. There were about 65 million users, and that accounted for 45%. And so here they are. They plotted. There's the first category, and that goes up 45%. And that goes up to 45%. The next category, 26 through 40, is 36%, and so that's plotted here. Okay. Here's just some examples of plots. We know about the pie chart already. Here's a kind of a neat example of a bar chart. You've got categories here. This one goes, it has positive y values, but it also has negative y values. And so that's kind of nifty. Notice the bar charts are separated, and they take the form of arrows. Okay, and so that's kind of fun. Here's a bar chart. You have these bins of not bin. You have these categories. So this is the increase in after-tax income by income group. So you have different income groups. Here's the bottom 20 income group, the second 20 income group. See, so they've divided everybody into 5 groups. The top 20. Let's see now. 1, 2, 3, 4, 5. Top 20%. And then top 10%. Top 5 and top 1%. Right. Okay. So anyway, and so there's their percent increase. Yeah, so notice the top 1% had the biggest increase in after-tax income by income groups. And look at this, in 2007 dollars. So throughout the length of the study here, they normalized the money. The value of the money. Okay. Change in real family income by quintile. Quin is 5. Quintile is what we're going to be talking about later, but basically it's just these. We divide everybody into 5. We divided the data into 5 groups. And this shows a very similar plot. So it is just an example here. Let's see, anything more I want to say about this? Over the same period, the lowest income fifth saw a decrease in the real income. Right, whereas, so the rich got richer and the poor got poorer. So that's what happened there. Okay, that's it for 2.1. Now I want to talk about 2.2, which is histograms, frequency polygons, and time series graphs. All right, the first of these is a histogram. A histogram consists of contiguous or abutting boxes. There's no space. There's no space in between the boxes. No space. Okay. A histogram has a horizontal axis and a vertical axis. The horizontal axis are the labels. Is labeled with what the data represents. The vertical axis is the frequency or relative frequency. The histogram, like a stem and leaf plot, gives you an idea of the shape of the data, the center and the spread of the data, how distributed it is. A good rule of thumb is to use a histogram when you have more than 100 data points. Okay, to construct a histogram, here's what you do. First, you need to decide how many bars or intervals you're going to do. These intervals are also called bins or classes. And how many are you going to use to represent the data? Okay, so after we do that, we need to choose a starting point, less than or equal to the lowest data. This will become clear later on. Then what you do is you create bins using evenly spaced intervals, and you count how many data is in each one of those intervals. Each one of those, we split up the data, the space where the data lies. We split up that number line, and we see where the data falls, and we count how many fall within that interval. These are the heights of the bars. Then, next, draw the bars. All right, let's take an example. The following data are heights in inches to the nearest half inch of 100 male semi-professional soccer players. The heights are continuous data since height is measured. And this is also, of course, as we know, ratio data. Okay, so the lowest data value here is 60, and the highest is 74. So when I'm creating my bins, well, first I need to decide how many bins I want. Well, let's just see. So there's 100. I'm maybe just going to say 8 bins. All right. So if there's 8 bins, what should the interval length be? So interval length. Well, let's see what the difference is. The biggest value is 74 and the smallest value is 60. That difference is 14. So maybe I divide that. If I divide that by 8, because there's 8 bins, so if I divide that by 8, I get 1.75, which is roughly 2. So I think I'm going to go ahead and just do 2 for my interval length. And then what I'm also going to do is I'm going to offset this first value just a little bit so that the first value lies comfortably within a single interval. So my first interval is going to be, let's say, 59.05. Wait, 59.95. And then I'm going to add, so that'll be my first value, my lowest value. And I want that to go to, and I'll add 2. So that'll be 61.95. I am adding my interval length to that, 61.95. Then I'm going to, my next bin or class is going to be 61.95. And then I add 2 to that, and I get that. 3 is going to be 63.95. Going to add 2 to that. And then again, next one, 67.95, 69.95. Wait a minute. 67 to 69.95. 69.95 to 71.95. Okay, so is it a 4, 5, 6, 7, 8? I'm almost done. 71.95 to 73.95, and then 73.95 to, and it's going to end at 75.95. Okay, great. So there's my classes. Now what I need to do is I need to count up how much data is in each class. I'm going to go ahead and use red and green for these. So my first class goes from 59.95 to 61.95. So that goes to right here. Okay, so there's my first class. I can see that there are, let me think, 5 of those. So there's going to be 5. My next class, which I'll do in green, is going to go from 63.5 to, that's it. That's it, because 64 is in class 3. So that's 3. The next one, 64, is within 3 point, so 63.95 is in between there. So 64, lots of 64s. I'm going all the way to 65.95. So go all the way to 65.9. Oh, right there. Right there. Let me erase. Whoops. There. Okay, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that's 15. So there's 15 within there. All right, next one goes from 66 all the way to 67.95. So it'd be here, 67.95. That is a very big, yeah, there's a lot in that. Okay, right there. Right there is where it ends. Let's see how many that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. I think 40. Okay, and that's in bin 4. Okay, then what's going on? Next is bin 5, which is 60. Okay, let's go back to red. 68 all the way to 69.95. So that includes all the way to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I've got 17 there for that one. Okay, I've got 3 more. That's 69 to 70, 70, 70, 71. Okay, right there. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. And then the 72, 73. Whoops, let's do this in green. Great, and then this one's in red. It goes till there. All right, 1, 2, 3, 4, 5, 6, 7. And 7, and then the last one is just 1. 1. Okay, let's quickly just add these up. So this right here is going to be, 8, plus that is 23, 63, 70, no, 80, 92, 99, and 100. Okay, great. So that's all of them. So here I go. I'm going to plot. Let's see. Let me get rid of that. Let me make it straight. Great. And then here. All right. And so this is going to be 59.95, and that's going to go all the way to 61.95 to 63.95, 65.95, 67.95, 69.95, 71.95, and then 73.95. All right, whoops. All right, so that's 1, 2, 3, 4, 5, 6, 7, and then the last one goes to 75. 8. There it is. All right, so this first one has 5. Okay, let's see. 5, 10, 15, 5, 10, 15, 20, 25, 30, 35, 40. Okay, so we've got 5, 3, 15, 40, which is like way up here. $17, 12, 7, and then 1. There's my histogram. It's got 8 bins, and each bin has anywhere from 1 to 40 players in it. Okay, there it is. There's the, that's pretty much the exact same thing right there. But now you see exactly where it came from. Okay, so you can just look at that if you need to. Frequency polygons. Frequency polygons are analogs to line graphs, and just as line graphs make continuous data visually easy to interpret, so too do frequency polygons. To construct a frequency polygon, organize the data as if you're graphing a histogram. It's exactly the same way. Just graph a histogram. Mark the midpoints. Okay, you got to find the midpoints of the interval on the x-intercept, on the x-axis. Then what you do is you plot the midpoints and the frequency for each interval. You connect it like a line graph, and then you go one step to the left and one step to the far right, and you intersect the axis. So plot points on the interval below the lowest midpoint with 0 frequency and 1 above with highest frequency. That way you make this polygon looking thing. So if I could direct your attention to this plot right here, this is a histogram. We can easily make it a frequency polygon. And the way to do that is just to find the midpoint, right there. There's a midpoint, here's a midpoint. Find the midpoint in each of the intervals, and then find the frequency associated with that midpoint there, and then go one more on either side, and then connect the dots into a polygon. Okay, there, that is a frequency polygon. It's just a line version of a histogram. Okay, time series. Global deaths. So here's an example of a time series plot. Now, we're not going to talk a lot about time series because it's sort of a little different. It's different data than what we're going to be concerned about. But you ought to know how to use it. So here's a plot. Global deaths from climate and non-climate catastrophes. So what do we have here? Climate-related deaths is in blue, and non-climate-related deaths are in red. And so it used to be in the 1920s that so many people were dying because of climate. At least it looks like that. Over 450,000. But in recent years, it seems to have come down by quite a bit. I don't know what this would, maybe 20,000 climate-related deaths now, which is lower than non-climate-related deaths. Now notice this is what is this? This is deaths per year per capita. Oh, I can't read that. Let's see. Zoom. Yeah. Okay, anyway, but see, so for each year there's a point, and they just put all those points together and they make this time series plot. In finance, you see a lot of time series plots. So this is days, every day, and every day has its own value, and they plot these values and they go up and down, and we connect it. And so here's another example of a time series plot. Here's another climate-related time series plot. See, so here's CO2 over the years. Now this has an interesting trend. The CO2 goes down, so I guess they probably take these measurements maybe monthly. Does it say? Seems to me like it might be monthly. We see this zigzag. It goes up and down and up and down. And I think that's reasonable because they say that during the spring, the plants absorb. The spring is a time of a lot of plant growth, and so the plants are absorbing a lot of CO2. And so in the spring, the CO2 goes down, and in the winter, the CO2 goes up. And I think we're seeing these annual trends right here with this zigzaggy nature. Okay, one more example here of a time series plot. At each year, there's the CO2 emissions, and so they just plotted it. There's 2003, and there's the emissions for that year. And then 2004, there's the emissions, and they connected it. All right, so that's sort of an introduction to a bunch of different plots. Okay, everybody, and that's the end of the video, so good luck on your homework and quiz.